Okay, good evening, everyone. So, this is your first lecture, right? And we are starting with the mechanics. Before you start asking a few questions, let me tell you a few things uh, that I missed yesterday. The first frequently asked question by the students are, can we write all GS paper in Hindi and physics optional in English? Yes, you can write. You can write remaining paper in Hindi and physics optional in English, right? Second doubt that they have asked, that can we use calculator? Calculator use is mandatory. Okay? You have to use calculator. Which type of calculator? Non-programmable scientific calculator. Write it down if you don't know. Non-programmable scientific calculator. Right? It will hardly cost you 250 to 500. Right? उसकी range में सारी आ जाती है. How many of you have calculator with you? Okay. Yes. The same you are used in the university. Same thing. Okay. Chalo. So let's start the class. So focus here. This is the mechanics portion, right? And you have two papers, paper 1 and paper number 2. Both comprises of 250 marks, as you all know, right? Both comprises of 250 marks, right? And this mechanics belongs to section A. Generally section A, exception is 1 year only, but generally section A of the paper number 1. Paper 1 का section A में mechanics आता है, right? And half of the weightage is devoted to the mechanics. There are two sections, mechanics, waves and optics. These are in the section A and both of them has equal weightage, right? Now, more analysis of the weightage we will doing at the end of this courses. Okay, why I'm telling you this, because if you analyze in the very first time, you will tend to lose interest in few topics. Those have very less importance, right? But you need to understand that they have to be studied for the concepts, right? Chalo. So let us start with that. The first topic is mechanics of the particle, right? Second topic is mechanics of reduced body. I guess these two topics you have studied in class 12th also, right? But how you will be changing the pattern of writing the answer, that you have to see now. For example, let me tell you a very small example, right? UPSC has asked to find out the center of mass of hemisphere. Center of mass of hemisphere. UPSC once asked center of mass of hemisphere. Everyone can derive it in half page, right? But the art is to write this in 1.5 page with proper presentation. Okay, so this is what we are going to do, right? Next is the mechanics of continuous media. This is the easiest topic in mechanics. Mechanics of continuous media is the easiest topic, along with the gravitation. And this is special relativity is a bit tricky, right? Or if you are studying for the very first time, you might confuse it, but we'll try to comprehend it in a better way, right? So first, how we will be doing the things? First, we will be completing mechanics of particle and rigid body, right? What is a rigid body? Anyone? Try to be interactive. You can use your audio and interact.
The rigid body is system of particle whose relative position is not changing with respect to
Yes.
time.
Very good. So rigid body is a kind of body, is a mathematical concept basically, rigid body, right? Whose distance between any 2 points is not changing with the time, right? So you need to understand that rigid bodies are also made up of particles. A condition is put on the particles that they do not change the position. That's why we have to study the mechanics of the particle first, and then we will move on to these things, right? How will we going to cover? First, need to understand. First, we will be going to start with the equations of motion, right? Now understand, equations of motion is written here only in the rigid body, but we have to study the equation of the motion of the particle also. Why? If you don't study the motion of the particle, then you cannot apply directly here. Also, few things are required for the central force motion, which is a very, very important topic in the mechanics. Yes, you डिस्टेंस टू पॉइंट नॉट चेंज. ठीक है, स्टार्ट करें फिर. एवरीवन कंफर्टेबल अभी तक हो गया है? यस, कैन वी स्टार्ट?
Yes, sir.
So we are interested here in studying the classical mechanics. Classical mechanics. The entire mechanics, we are telling it as classical mechanics. Can anyone tell me what do we understand by classical mechanics? Anyone? What do we mean by classical mechanics? तो दोनों चैट पे भेज रहे हैं.
मैक्रोस्कोपिक बॉडीज का जो मोशन होता है उसको स्टडी करते हैं क्लासिकल मैकेनिक्स में विदाउट डीलिंग विद द कॉज. पहले तो अगर वैसा कहना
नहीं, और तो पढ़ते हैं.
वो काइनेमैटिक्स हो गया.
मैकेनिक्स क्या होती है? This is between quantum and relativistic mechanics. Between, okay, more finer one. Try karo. See, in the examination, you have to write the introduction, right? And most of the introduction will revolve around the definition of the thing. Okay, so try to answer. Everyone, एक attempt मारो, सब लोग.
मैक्रोस्कोपिक सर.
Macroscopic. Okay. What is the macroscopic? Study the macroscopic with the velocity less than the light of speed 9. Who is telling you? Aditya, Swamya, both of you are writing the non-relativistic part, right? See, here also we have special relativity. Now, you need to understand the thing between the classical domain and the quantum domain. Classical is classified according to the quantum perspective. Quantum means the modern science that we are adopting right now. And these are classical mechanics is used for macroscopic objects. What is so cool about this macroscopic object? Macroscopic objects are basically distinguishable. Macroscopic objects are basically distinguishable, right? Can anyone tell me what is distinguishable? Can anyone tell me what do you mean by distinguishable? Though starting with थोड़ा बहुत, it might be slow, right? But I want everyone to participate first. Because when you speak ना, तुम्हारी ability बढ़ती है सोचने की और लिखने की. So please tell.
तो जिस चीज को सेपरेटली देखा जा सके, that is distinguishable.
जिस चीज को
सेपरेटली देख सकते हैं.
सेपरेटली देख सकते हैं. Okay. Anyone else? Want to try?
सर जिस ऑब्जेक्ट को ओपन आई से देखा जा सकता है।
जिस ऑब्जेक्ट को ओपन आई से देखा जा सकता है, ओपन आई की तो लिमिटेशन बहुत छोटी है ना। ओपन आई की तो लिमिटेशन बहुत छोटी है। और सोचो।
जिसका कंपैरिजन आसानी से किया जा सकता है सर, ऐसा ऑब्जेक्ट।
जिसका कंपैरिजन साइंस से किया जा सकता है। ट्राई
सर
करो
वो
और बाकी।
ऑब्जेक्ट जिनका लेंथ ब्रीथ और हाइट मेजरेबल हो।
लेंथ ब्रेथ हाइट में दैट मींस वॉल्यूम, particles
Yes.
which are not entangled. Okay, everyone, भाई मैं सबके लिए वेट कर रहा हूँ।
So, like in quantum mechanics, particle acts as a particle also and wave also. So here, I think means here in classical mechanics, it acts as only particle. We can't means it won't act as a, like a wave. Like we don't see it like that, I think.
Which are not identical, distinct bodies. चलो, see, this is the basis that I want to discuss. If I want to classify the matter on the basis whether it is alike or not, I can write in terms of two. Let us write here that matter, any matter or any particle, any matter or particle can be described as two. First one is non-identical. See, non-identical is always indistinguishable. यार प्लीज पहले ज्वाइन कर लो, बीच बीच में मांग लो तुम लोग लिंक, ये फ्लो डिस्टर्ब कर रहा है, ठीक है। प्लीज आई रिक्वेस्ट एवरीवन, कल से 5 मिनट पहले ज्वाइन कर लेना, मैं भी कर लूंगा, ठीक है। बट प्लीज बीच में लिंक मत मांगो, इट इज हैम्परिंग द क्लास इटसेल्फ। एक मिनट जो, ये 1-2 दिन दिक्कत आएगी यार सबको, ठीक है। सॉरी फॉर दैट, बट ठीक है। देखो, we can differentiate like separate properties. Yes. See, if we can classify matter on the basis of the properties, right? On the basis of the properties, there can be two matter, not identical, that is having different properties. Different properties can be anything. Like their shape can be different, their material can be different, right? Their structure can be different, their refractive index, let's say, can be different, all those things. But there are few something which we call in mechanics or in physics, they are identical. Identical particles or matter. What are identical particles? Identical particles are those which have all same properties. Same properties. Now you need to understand that it is not the matter whether you can differentiate or not. It is distinguishable, right? And now this identical particle is categorized into these two terms. This clarity should be there in your mind. Otherwise, कुछ भी लिख दो examination में. These two, now they are classified as distinguishable and non-distinguishable. ठीक है? So this can be written as distinguishable and indistinguishable. Now the complete paper one deals with the distinguishable object. 90%. In statistical physics, you will find few topics in which we will have indistinguishability. Now, everyone understood this thing, that matter are divided into two categories, non-identical and identical. If they have all same properties, matlab mass same, color same, volume same, shape same, every property is same. If everything is same, they are classified as identical particles, right? Otherwise, they are not classified as, they are classified as non-identical particle. So what comprises of their distinguishability, right? They are not mere some English word. You to understand, they are not mere some English word, but there are some parameters. So I'm writing few parameters that you need to remember and understood, right? First parameter is changing position. Changing position. Okay? Does changing position affect the system or not, right? So if it is a distinguishable object, it will affect the system. If it is a distinguishable subject, it will affect the system. Anyone? What does it mean? Affecting the system. And if it's non-distinguishable, it will have no effect. Thought of any example? Anyone? Thought of any example? Second parameter to judge is analyzing the trajectory. अब देखो ये जो मैं लिखवा रहा हूँ ना सारी चीजें, it will help you to write conclusion. How? We will see in the launch session, है ना? Can you analyze the trajectory? Yes, you can analyze the trajectory. Here, you cannot analyze the trajectory. Based on these two parameters, you can define whether it is a distinguishable object or not. ठीक है? Distinguishable object or not. For example, let me give you some example here. Distinguishable object. Let's say if you have 4 blue balls. If you have 4 blue balls, all of them are same. All of them are same. For example, let's say this is ball 1, this is ball 2, this is ball 3, this is ball 4, right? All of them are same. I am numbering it. 1, 2, 3, and 4. All blue balls, उस पे marking भी नहीं है. No marking on it. I'm just telling you. If you change 1 with 3 and 4 with 2, will it change the system? No. For example, rice, right? For example, rice, grains, all of them are identical. If you put, let's say, अगर तुम्हारे पास rice है एक कटोरी में, if you have multiple rice, if you pick this one and exchange with this one, will it affect the system? No, it will not affect the system, right? First example, second example. Third example is your atoms. Let's say you have studied about the unit cell. In unit cell, you have studied about that the atoms are placed at their corners. The atoms are placed at their corners, right? So if atoms are placed at their corners, these are the atoms. Even if you change one with another, it will not make any sense. It will not make any sense, right? Also, let's take fourth one. If you have 2 balls, let's say you have two balls. This is ball number 1, this is ball number 2. Let's say both of them are exactly same. They are identical balls. And this is the trajectory of the first one. Let's say in this way it is moving, and this is the trajectory of second one. Let's say they're intermingling, whatever. But if at any time, if you can judge that this is the trajectory of one, this is the trajectory of two, then these objects are our distinguishable object. समझ आ रहा है क्या बोला जा रहा है कि अगर हम लोग, हमारे पास कोई चीज है जो डिस्टिंग्विशेबल हम कह रहे हैं, तो दो पैरामीटर जज करना है हमें. अगर वो मोशन में है, मूव कर रहा है, तो उसकी ट्राजेक्टरी देखो. अगर तुम उसकी ट्राजेक्टरी को समझ पा रहे हो कि हाँ ये इसकी ट्राजेक्टरी है, तुम ट्राजेक्टरी को डिस्टिंग्विश कर पा रहे हो, तो वो पार्टिकल कैसे है, डिस्टिंग्विशेबल. दूसरा पैरामीटर क्या है कि उसको एक दूसरे से रिप्लेस करके देखो. अगर वो रिप्लेस हो गए, राइट, अगर वो रिप्लेस हो गए और कोई भी इफेक्ट नहीं आया सिस्टम पे, देन दे आर डिस्टिंग्विशेबल ऑब्जेक्ट. Yes, moving ball. Yes, Shakti. Now, here, indistinguishable object you cannot imagine right now, right? When we will study second paper, you will get to know this thing. But again, proton, electron in an atom. Let's say. Now you know that this is your atom. Let's say this is your nuclei. This is your what? This is your nuclei, right? You have proton, you have neutron here, right? Where is proton present inside the nucleus? You cannot say that. You will just say that within this boundary, all the protons and neutrons are available. But exactly where is the proton? You cannot say. Same goes with this thing. Let's say you have studied about the orbitals. पढ़ा ना junior classes में. 1s, 2s, 2p. Have you studied about these things? Class 12th. Yes or no?
Yes, sir.
So let's say if this is your 1s orbital. What is 1s orbital? If you remember your junior classes, 1s orbital is a spatial probability, right? It is the reason of spatial मतलब space वाला. It is the region of spatial probability. That means, can you exactly tell me where electron is there? You will tell the first electron is going to 1s orbital, but where? Can you pinpoint the position? You cannot say that. ठीक है? So all those things comes under indistinguishable object, right? So here just write out all the quantum particles. More discussion we will be doing when we will study the quantum mechanics, right? More discussion we will be doing when we will be studying the quantum mechanics. Everyone clear with this thing or not? So if it is distinguishable, right? If it is distinguishable, if any object is distinguishable, we can predict the position and the momentum. What is momentum? Momentum is nothing but mass multiplied with its velocity. Basically, if an object is distinguishable, we can predict its position and velocity. With respect to time. With respect to time, right? Now, what is this? This predicting position and momentum with respect to time. इसी को तुम बोलते हैं इक्वेशन ऑफ मोशन. इक्वेशंस ऑफ मोशन. This is what we call as equations of motion, right? This we deal by the equations of motion, right? So let me give you an example. Let's say if position is something like that, 5t square plus 4, 5t square plus 2. Just by this thing, are you able to find out its velocity and position with respect to time? Can you find out, everyone?
Yes,
sir.
sir.
Yes, sir.
And this is what we are calling as equation of motion. यही तो equations of motion है, right? If you differentiate it,
Yes, sir.
velocity will be what? 10t, right? I guess it is right. So if you have t is equals to 1 second, you can simply say that ki x is equals to कितना आ रहा है देखो तो 9 meter, and v is equals to 10 meter per second. At t equals to 2, x is equals to कितना जाएगा 4 20 24 meter, and v is equals to 20 meter per second. No, this is what we call as equations of motion. That if I give you time, you have some equations. If you put time there, you will find out its position, momentum through time, right? This you cannot do for quantum particles. This you cannot do for the quantum particles. You have studied this also in your junior classes. Can anyone name this thing? You have studied this, that position and momentum cannot be found
Sir,
from.
Heisenberg's uncertainty principle.
Very, very good. Very good. So yes, the paper 2 start with this law only, Heisenberg uncertainty principle, that you cannot find out the position and momentum with respect to time with accuracy. And this is what is possible here, right? Now, note down here, there is one exception here. Exception. You need not to look into these things. Bas likh lo. That is chaotic system. If the system is chaotic, these things are not applicable. These things are not applicable, but still, write down the exceptions is chaotic system. It will help you in writing the conclusion. Now, can anyone define the equations of motion for me? एग्जाम में जब भी आता है ना, जैसे पूछा भी गया था, write down the equation of motion for a body doing this thing. So equation of motion, so see, understand what we write in the introduction, right? We write the keywords from the syllabus. We are studying this. Equations of motion. This is written in the syllabus, right? So equations of motion को define करना होगा हमें, right? Everyone? सबसे मैं पूछूंगा फिर I will write. What do you mean by equation of motions? Equations of motion. सबको पता है. I know this thing. All of you know this thing. What is equation of motion? But to put down in the verbal format, it is the challenge, right? So I want everyone to just try it out.
Sir, finding the relation between position and the momentum of velocity.
Finding relation between position and momentum. Okay, ठीक है. और आगे बढ़ो. Movement of particle represented in an equation. ठीक है. I'm giving you 2 minutes, everyone. Please chat पे लिखो या बता दो. मैं तुम्हें बुकिश आंसर लिखवा दूंगा, टेंशन मत लो, बट प्लीज ट्राई एवरीवन. relation of position and space with time, yes. But see, समझो, तुम्हारा अगर आंसर स्टार्ट होगा, प्लीज ट्राई टू राइट इन दैट वे. चलो थोड़ा सा डिफाइन करके लिखते हैं हम लोग. इक्वेशंस ऑफ मोशंस are the relations that describe and predict. There are two words, describe and predict. The motion of a physical system with respect to time. With respect to time. और इसको लिख सकते हो as a function of time. As a function of time. Now, can anyone tell me what is the difference between predicting and describing the system? What is the difference between predicting and describing the system?
प्रिडिक्ट मतलब वो किस पोजीशन पर मौजूद है उसका अनुमान लगाना सर, और डिस्क्राइब मतलब वो उसकी पूरी उससे पूरा डिटेल से इसका जानकारी देना सर.
See, describe is basically present, and prediction is basically in physics is both past and future. Prediction is basically both past and future, right? So if t is equals to 5 सेकेंड, अभी 5 सेकेंड हुए हैं मोशन के, तो आई कैन ऑल्सो प्रोवाइड द इंफॉर्मेशन कि अभी कितनी स्पीड है उसकी, है ना, एंड आई कैन ऑल्सो टेल यू कि 10 सेकेंड बाद क्या स्पीड होगी उसकी. So describing this in present now is 5 seconds, and describing it at a later time is the prediction, right? This is the word that you have to understand, that you can describe the system and you can predict the system. There are few instances where you cannot describe the system, but you can predict the system. ठीक है? For example, सुनना अच्छे से, for quantum particle description, you cannot describe the system as such, but somehow you can predict the system. Somehow you can predict the system, right? So we will not go into these intricacies, but try to understand एक एक वर्ड समझो अच्छे से कि डिस्क्रिप्शन क्या है. प्रेजेंट में अभी अगर मान लो t is equals to 4 सेकेंड अभी है, 4 सेकेंड हुआ है मोशन स्टार्ट हुए, तो we can describe it now also, and we can describe it at a 10 second also. Also we can describe it 2 second. So this 2 second and 10 second is associated with the predicting the motion of this physical system, right? And description is now what is the status. Everyone clear with this thing? Yes, very good, Ayub. We describe the system in real time, exactly, and predict in the future. Be conceptually very clear whatever we are teaching here. Okay, chalo. So this is the classical mechanics. Now coming to the concept of particle. We always say particle. What is a particle? And this will help you to assume few things, right? What is a particle? दो स्टार्टिंग के 3-4 क्लास में आई विल बी अ लिटिल बिट स्लो, सो दैट तुम लोग सब लोग पेस्ट पे आ जाओ, बट प्लीज आ जुड़ जाओ. विच हैज मास, ठीक है, एवरी थिंग हैज मास, राइट? विद पार्टिकल, लेट मी टेल यू, इट इज related to the point object. Point object, what is a point object? See, when you are writing these kinematic equations, these equations, when you're writing equations of motions, are you considering the size of the body? No, we are not considering the size of the body. We are not considering the shape of the body. That means it is irrelevant of the shape. Whether a ball follow this equation or a car follow this equation, all the parameter will remain same, right? So there need to be we need to understand that we are considering all of them as a particle, and that is a point object, right? Now, to understand, the concept is relative. It is a relative concept. Particle is a relative concept. For example, if you watch the moon from the earth, you will say that moon is a point object. Forget about the moon. If you see the star from the earth, you will say that the stars are particles. Why? Because the distance between them and the size of this is very, very large. So a simple thing to understand that how we define something as a point mass or one. So these two concepts, that is infinitesimal. Have you understood this portion? Point wala.
Yes,
Infinitesimal versus infinity. Now, these are a very relative concept, that what things are infinitesimal and what things are infinity, right? Let's say, for example, a wall in front of me is not an infinity, but if you put a very, very small, tiny ant in the wall will look like infinity for that. So this is the parameter of judging a thing, whether it's a point object or not, or when we can apply the equations of motion without considering its shape and size. This is the function. When the size of the object is much less than the associated distance, then we can consider it as point mass. When size of the object is equivalent or greater to the associated distance, these are called extended object. And when we call it extended object, then its shape and size matter. What a moment of inertia, hollow sphere, different moment of inertia, it will behave different. It will give different parameters to the motion of equation, right? Solid sphere will give different. So these are the things that whether it is an extended object or a point object, it is the matter of what? It is the matter whether sorry, whether the size is same or not. How many of you have solved the SC Verma? 11वीं बारे में कितनों ने SC में सॉल्व किया है? नहीं किया क्या? SC Verma नाम तो सुना होगा, right? So if you have studied for JEE in any point of in life or solve SC Verma, वहां पे कुछ क्वेश्चन होते हैं. Let's say if this is my car, ठीक है? This is my car, and if this car is having a length of 5 meters. Now, two cases I am giving you. The first case is when it is traveling the distance of 10 kilometers. And second, when it is traveling a distance of, let's say, 20 meters. In which of this scenario it can be treated as a point object, and in which scenario which it can be treated as an extended object?
the first one as a point mass, and in the second case as an extended object.
The first one as a point mass and second one as an extended object, right? This अब देखो कभी भी कोई न्यूमेरिकल आए, जस्ट बाय सीइंग दीज टू पैरामीटर, कैन यू टेल मी, तुम तो बता सकते हो ना अच्छे से कि whether you will add the length of the car or not, whether you consider the length of the car or not, right? Just by seeing the numbers. ठीक है? So understand, in physics optional, number play a very important role, right? I will tell you how to write the interpretation of the numericals. ठीक है? कुछ टाइम के बाद, एक दो क्लास के बाद वो सब चीजें आएंगी, है ना? But from here you can judge here, right? कि just अगर same question हो, सबको same, this is traveling at a speed of 20 meters per second, its length is 5 meters per second, just by changing the distance your answer will change, and the mode of interpretation in the examination will change also, right? Just acknowledge this thing. How it will be, we will be doing, I will tell you. Okay? Now next example I'm giving you. Let's say this is your sphere, right? This sphere we will be doing in gravitation, है ना? Let's say if this is the sphere, the radius of this sphere is r, and this is the point where we want to find the gravitational potential energy, let's say, right, which is at a distance r from here. Can anyone tell me, if I will apply the formula of that gravitational potential energy, if I apply the formula of that, what should be the relation here between r small and greater r?
Sir, R is very much greater than capital R.
सी, अब तुम्हें अगर याद होगा, आई होप कि तुमको सबको, सब लोग 11th तो पढ़ कर आए हो ना, एवरीवन 11th पढ़ा था GMM by r square, पॉइंट मास के लिए, याद है GMM by r something?
Yes.
Yes, sir.
So, what we do in our university examination or in our school days, we take those formula as granted. We never write the underlying assumption. But in UPSC, when you're writing the answer, you have to write the assumption. If you're writing the formula of GMM by R, that means you are treating this as a point object, and this will be treated as point object only. It can be treated as a point object only if R is greater than R. So when you're writing your answer, you will write that assuming the small r is much greater than the capital R. Then you will apply the formula. Otherwise, your formula will lose its validity. Okay? One more example I'm giving you. Let's say this is the earth. Okay? This is the lovely earth, and we are standing on this earth, let's say. ठीक है, this is my earth. अच्छा, तुम लोग कलर मत करने लगना, है ना? ये सब इसलिए होता है सर कि you will be able to, and you are standing here, let's say, ठीक है? And तुम खड़े हो इंडिया गेट के सामने. इंडिया गेट तो देखा होगा सबने, कुछ ऐसा ही है, ऐसा ही है ना कुछ, थोड़ा थोड़ा. कुछ ऐसा है इंडिया गेट, लेट्स से, ठीक है? So let's say this is your India gate. This is your India gate. Now, I write it a bit slow so that you are making your, how many of you are making notes? कितने notes बना रहे हो? Raise your hand. You can just raise your hand. I will. Yes, please make your own. Yes, very good, very good. ये तो रेफरेंस के लिए है ना? तो ये जो कलरफुल रंगीन चीजें होती रहेंगी, it just mean कि तुम कोप अप कर रहे हो राइटिंग के साथ, ठीक है? Now, here we have a star. Here we have a star in the sky. Now, star is very far away from us. Now, let's say the distance, it is D1. We are standing at a distance D1 from the India gate, and the star it has D2. right? And we know that D1 is very, 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 very less than the D2. We know that D2 is very, very, very less than the D2, right? So what I will feel, what I will say here, that the star is very, very less. That is, the dimension of star is negligible as compared to India Gate. As compared to India Gate. That means whatever I am quoting here, it is with reference to me. I am saying this thing. That means it is a relative concept. That is, this very concept, it is a relative concept. Now, when things are relative, कि मेरे हिसाब से कुछ और तुम्हारे हिसाब से कुछ और, they don't feel कि एग्जामिनर को बताना चाहिए था ये चीज. You can lower your hand. Everyone. कि एग्जामिनर को मैं बताना चाहिए कि हम लोग ये सोच रहे हैं कि मेरे हिसाब से इसकी डायमेंशन छोटी है, राइट? फॉर मी इट इज वेरी वेरी स्मॉल. ठीक है? सो यू नीड टू अंडरस्टैंड हियर दैट original size do not matter. Original size do not matter for considering any object as point or extended object. What matter? The associated distance. But the associated distance. Now, इतना भाषण देने के पीछे रीजन बस एक ही चीज है. Only one thing I want to convey here, that you will write in note here. Write down in note that answer writing में you will use this thing. Note. While writing answer, you have to write this thing, right? So assumption of object as point object must be specified in your answer copy. लाइव आंसर राइटिंग टाइम पे हम लोग देखेंगे इसको अच्छे से. बट assumption कि एग्जैक्टली तुम्हें क्या लिखना है assumption पे, बट assumption must be written. I have already told you कि when you are making your notes, है ना, तो इधर ये नीचे थोड़ा सा ब्लैंक छोड़ दो, मतलब 10% बिलो और 10% इन दी साइड वाइज फॉर द वैल्यूडेशन मटेरियल. ठीक है? वो बाद में चलेगा कैसे करना है. ठीक है? एवरीवन प्लीज रेज योर हैंड इफ यू हैव अंडरस्टूड टिल नाउ. चलो ठीक है. अच्छा एक चीज और, हम लोग कैन वी इंक्रीज द स्पीड? आई थिंक वी कैन इंक्रीज द स्पीड आल्सो, है ना? Okay, we will increase that. दो क्लास में तुम्हें कभी ऐसा फील नहीं होगा कि एनीथिंग इज गोइंग एट अ वेरी वेरी फास्टर स्पेस. आराम से करेंगे, सब कुछ खत्म हो जाएगा. नेक्स्ट इज इवेंट एंड ऑब्जर्वर. सी दीज आर द बेसिक्स ऑफ आंसर राइटिंग. जब तक इन चीजों को तुम
सर
हाँ
एक डाउट था सर. जैसे जब इलेक्ट्रोस्टैट्स पढ़ते हैं तो उसमें जो रिलेशन लिखते हैं, अगर एक सॉलिड चार्ज स्फीयर के अराउंड अगर एक मेटल स्फीयर है तो उसके रेडियस के बाहर, मतलब स्फीयर के बाहर चाहे कोई भी डिस्टेंस हो, उसमें हम उसको जो डिस्टेंस लेते हैं वो प्रिज्यूम करके चलते हैं कि हमेशा वो जो डिस्टेंस है वो रेडियस से ज़्यादा ही होगा. बट तो सर वो वैलिड है फॉर्मूला, क्योंकि फिर वो तो किसी भी डिस्टेंस के लिए हम लेते हैं ना. और ये तो जो वैलिड होगा ये जस्ट कि जब वो जो डिस्टेंस हो उसके रेडियस से ज़्यादा हो, मतलब इनफाइनाइटली लार्ज हो, तभी वैलिड होना चाहिए. तो वो लॉजिकली करेक्ट है वो चीज।
देखो, जब इलेक्ट्रोस्टैटिक्स में हम लोग करते हैं तो वहां पर एक आता है कि उसके अंदर चार्ज कितना कंटेंट है, उसको बेसिकली तुम लोग गॉस थ्योरम से निकालते हैं, ठीक है ना?
यस।
वैसे हाँ, तो वहां पर वो अप्लाई होता है। आई एम जस्ट सेइंग कि अगर तुम्हारे पास कोई भी ऐसा फॉर्मूला है जिसमें हमने उसको पॉइंट मानकर अज्यूम किया है ना, एट अ वेरी लार्ज, फॉर एग्जांपल डाइपोल का कॉन्सेप्ट समझ लो, है ना? हम क्या बोलते हैं कि डाइपोल बहुत ही छोटे डिस्टेंस पर है, तो वो हमें स्पेसिफाई करना होता है। आर गेटिंग इट?
यस सर।
वो चीज है। इसकी एप्लीकेशन धीरे धीरे समझ में आएगी तुम्हें कि हाउ वी विल बी अप्रोचिंग दिस। ठीक है, नाउ व्हाट इज एन इवेंट? एनीवन? व्हाट इज एन इवेंट? with respect to time, yes. So event is nothing. Event is basically the mathematical model of any phenomena. Mathematical model of a phenomena. ठीक है? Event is nothing but a mathematical model of a phenomena, right? For example, let me tell you one thing. Let's say here it is water. Okay, a ray of light comes here. This is my normal, and it get refracted here, right? You have, you know that this is angle I and this angle R, angle of incidence and angle of reflection. सबको पता नहीं इन चीजों का? जो पता ना हो बता देना मुझे, बट आई एम अज्यूमिंग यू दीस थिंग्स यू नो, है ना? सो एंगल I and angle R. So what is the phenomena here? What is the phenomena here?
Refraction.
What is the mathematical model of refraction? What is the event here? The mathematical construct. It is the Snell's law. That is, I can write this as mu1 sin I is equals to mu2 sin R. This is the difference between phenomena and event. Bas. Event is just the mathematical manifestation of that model. Okay. For example, if you talk about mechanics, in mechanics, what will be the event? Event will nothing but the position and time construct. Position and time, nothing more than that. ठीक है, जितना पढ़ना है उतना ही पढ़ाऊंगा, ठीक है, टेंशन मत लो, कुछ भी एक्स्ट्रा नहीं है, एवरीथिंग हैज अ मीनिंग, ठीक है? व्हाई आई एम टेलिंग यू दिस, बिकॉज इफ यू कंपेयर दीज नोट्स विद अदर नोट्स, है ना, तो मुझे लगेगा कि ये सब चीज तो उधर है ही नहीं, है ना, या टॉपर के नोट्स में नहीं है, बट ट्रस्ट मी, दीज स्मॉल स्मॉल थिंग्स, हाफ ऑफ पेज थिंग्स, yes Ayub, will make difference in your answer writing. You will feel it. ठीक है, चलो. Now, what is an observer? Who is an observer?
Who is observing the event?
When we need an observer. In physics, when we need an observer. छोटी छोटी बातें पे ध्यान देना, यहीं से नंबर कटते हैं और बनते हैं. I will tell you. Who is an observer? Sorry, why we need observer? Or when we need observer? Now, पूछो, सुनो. When I ask you, what is Snell's law? Aditya, tell me Snell's law. Just mathematical. लिखवाया अभी तो.
Mu into sin theta is constant. फर्स्ट लॉ और दूसरा
यही है, mu1 sin i equals to mu2 sin r, यही बोल रहे हो?
यस सर
दीक्षा, लखन एंड अर्चित, इज इट सेम फॉर यू? यही बोलोगे या कुछ अलग है तुम्हारा? यस, नो?
Same, sir.
Same na, right? That means it doesn't specify any observer. Yes, brother. It doesn't specify any observer. If I ask you Snell's law, if I ask you Newton's second law, F is equals to ma, although it's not F equals to ma, but the formula is F equals to ma. Everyone will say this thing, right? Now I ask you the second question. What is the reason of poverty in India? Write it down. Everyone, write it down. What do you think is the reason of poverty in India? One reason only. कोई भी reason लिखो. Lack of education, lack of resources, unemployment, uneven distribution of wealth. सबका अलग अलग है. Literacy सबका अलग अलग है. Are you getting it? That means from Aditya perspective, it is lack of education. From Archit perspective, it is lack of resources. From Soumya perspective, it is unemployment. From Ayu perspective, it is uneven distribution of wealth. From Surendra perspective, it is literacy. That means when things are relative, when things are subjective, when there is subjectivity involved, then you have to specify who is saying that. Are you getting it? These are the basic skill. तुम जब बोलते हो तो अभी बोलते हो ना मेरे हिसाब से ऐसा कुछ है. मुझे लगता है कि lack of education is the prime reason. Are you sure कि वही reason है? No, you're not sure. ठीक है? So understand, when we need observer when we have when we need to describe any relative concept. Whenever there will be a relative concept, you need observer. अभी चीजें और clear होगी. Why I'm telling this thing, right? What the observer will do, what he will do, he or she जो भी है, observer क्या करता है?
Observe the event.
Yes. First, observer measures the thing. Second, he write out its observations. Measurements लिखते हैं, observations लिखते हैं, ठीक है? Third, what they do? They do experiments. And fourth, the most important is their interpretation. Right? So now when you're writing any answer, बहुत heavy तो नहीं होगा किसी के लिए ना? I am taking it very very slow और आराम से चीजों बता रहा हूं मैं. So why interpretation is important? Because when a question will be given, either they will ask you derivation, that is the experiment, or the observation or measurement. They will give you by numerical. So these can be find out by the numerical. What we have to focus upon the interpretation part, right? Because observer do these things, right? These are the tools that observer uses. These are the tools of the observer. Okay. Now, if it has a tool, right? This tool need a workplace to work upon, right? And that workplace, it is applied by in a reference frame. Applied in a reference frame, right? So when we talk about velocity, position, all those things are relative concept, right? So note down, note for your answer. Always specify reference frame in your answer. कुछ भी कहीं समझ नहीं आया, प्लीज डू आस्क. बाय डिफॉल्ट इट इज ग्राउंड फ्रेम, जो बचपन से पढ़ रहे हो, या हम लोग अब क्या यूज करेंगे ग्राउंड फ्रेम को? लैब फ्रेम बोलेंगे. क्या बोलेंगे? लैब फ्रेम. नाउ लेट अस अगेन सी दी syllabus. Center of mass and laboratory reference frame. Center of mass and laboratory reference frame. Are you getting it? Everything is mentioned in the syllabus itself. We have to just decode this syllabus and use in the answer writing. ठीक है? So whenever, अभी तो दूसरी क्या सीखी answer writing में? That we have to use, if it is a point object, we have to specify it. Second is that we have to specify the reference frame that we are using. ठीक है? डन 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 डन, जल्दी बताओ.
सर आपने बोला कि ये टूल्स फ्रेम वी रिक्वायर्ड अ वर्क प्लेस. व्हाट इज, कैन यू एक्सप्लेन दिस वर्क प्लेस? आई डिडंट अंडरस्टैंड दैट.
Workplace, that means if you're observing, right? You're measuring. You will be measuring from somewhere.
Yes.
Reference point will be there कि तुम कहाँ से measure कर रहे हो, है ना?
Okay, okay, yes, got it. एंड सर एक समझ में नहीं आया, वो आपने जो एक्सप्लेनेशन दिया था स्नेल्स लॉ के उधर, वो नहीं समझ में आया थोड़ा. मतलब आप क्या बोल रहे थे वो समझ में नहीं आया थोड़ा. जो स्नेल्स लॉ के बारे में, इवेंट के बारे में जो एक्सप्लेनेशन था ना, जो स्नेल्स लॉ लिखा है, वो समझ में नहीं आया.
मैं बोल रहा हूँ कि इवेंट और फिनोमेना में क्या अंतर है, राइट? तो ये जो रिफ्रैक्शन हो रहा है, इट इज अ फिनोमेना, है ना?
यस यस यस.
तो अगर हम मैथमेटिकली लिख दें तो वो उसे हम इवेंट कहते हैं. ठीक है? मैथमेटिकल मॉडल और मैथमेटिकल कंस्ट्रक्ट ऑफ एनी फिनोमेना इज दिस. ये इक्वेशन ला रहा ना कि ये रिफ्रैक्शन की इक्वेशन है, ये सुनो.
यस सर.
इवेंट ऑफ दैट. ठीक है?
ओके सर, अंडरस्टूड.
चलो, next is space time. So I will not talk about time as of now. जब हम relativistic domain पढ़ेंगे तो for now assume that time is same for everyone and coordinate systems. When we talk about the reference frame, everything is sync. हम लोग जा रहे हैं, है ना? Space time and coordinate system. No, understand this thing. Time is again a relative concept. Let me tell you, when we will start the relativistic domain, I will tell you that time too has relativity. But for now assume to be same for everyone. As of now, अभी के लिए इतना समझोगे. अभी के लिए हम क्या मानेंगे कि सारे ऑब्जर्वर के लिए टाइम इज सेम, राइट? टाइम इज सेम. नाउ टेल मी, व्हाट इज स्पेस? व्हाट इज स्पेस? एनीवन वांट्स टू डिफाइन इट? व्हाट इज द स्पेस?
Sir, region of the surrounding under the observation.
They are basically coordinates, है ना? So set of all possible positions is your space. Set of all possible positions that the body can occupy. Right? This is the space. अब देखो, whatever I am teaching you, trust me, all this will make sense. अभी when we will start the paper number 2, you will have mu space, you will have k space, you will have p space. तो वहां पे लोग बच्चे परेशान होते हैं ये क्या नई चीज आ गई. भाई अगर तुम सीख लोगे उसको मैकेनिक्स में ढंग से कि एक्चुअली में किसको डिफाइन करते हैं, then you will be at a good position, right? For example, if I'm writing here, this is my x coordinate, this is 0, this is positive x, and this is negative x. Okay? Tell me the space here. What is space here?
X-axis.
X-axis. Mathematically लिखो.
X.
minus x2 plus x.
X-axis.
Minus x2 plus x.
Plus.
Mathematically लिखो यार. That is minus infinity to
Minus x to x. That's right.
infinity, right? If I made this is x is equals to a and y is equals to b. What is my space? ये चीज तुम्हें पेपर 2 में क्वांटम मैकेनिक्स में एज वेल एज सॉलिड स्टेट फिजिक्स दोनों में काम देगी. ठीक है. माइनस एक्स टू एक्स. व्हाट इज स्पेस हियर?
Sir, x less than 0 to a and y less than 0 to b.
Very good. So x less than 0 to a and y less than 0 to b. This is my space. This is my space, right? So you need to understand space is the all possible position that it can occupy. ठीक है? It can only occupy this thing. So जब हम लोग solid state पढ़ेंगे तो there is a solid, उसकी कुछ lattice पैरामीटर होती है ना? Then I will tell you कि इसकी space कितनी है. ठीक है? चलो. Now, is space is always continuous or not?
Always continuous.
Continuous? Sure हो?
Sure, sir.
सर ये स्पेस ब्रेक भी तो हो सकती है ना सर?
कैसे?
So not necessary.
Yes. It is continuous in classical domain. ठीक है. इसका एक बहुत अच्छा इंटरप्रिटेशन है. पता है क्या इंटरप्रिटेशन है? Can you tell me? That means graphs can be made. This is the interpretation. When you go into the paper number 2, you will find very less number of graph. Or if you have graph, they are not continuous. There will be discrete, only points will be there. ठीक है. Continuous और non continuous तो सबको समझ आता है ना? Yes or no? These are discontinuous function and this is a continuous function, right? So this can be made. Graph can be made easily. बन तो सकता है. Graph can be made easily. You can easily make the graph. ठीक है. So understood. So that अगर graph easily बन सकता है, so should we make graph in our conclusion? Yes, we can attempt that. It will fetch more marks. It will fetch some validation material. ठीक है. So this is the part of that. ठीक है. What are coordinate system? जो तुम्हें पढ़ने हैं. See, coordinate system I will be teaching you again and again. ठीक है. I will be teaching you the 2D system in mechanics because we required only 2D system in mechanics. 3D we will be teaching in you in HCT and magnetism वाला part. ठीक है. What are coordinate system? यार, what is coordinate system? Coordinate system are orthogonal sets of axes. They are orthogonal sets of axes. ठीक है, यही तो होता है ना, और भी कुछ है? They all are orthogonal sets of axes. What does this orthogonal means? Anyone?
90 डिग्री के
90 degree है.
perpendicular to each other.
एंगल 90 डिग्री होगा सर।
Dot
Other
product
two?
is 0.
Very good, very good. This is what I want. If two things, let's say, are 90 degree, that means if A and B, that means their projection that is dot product on each other is null. null को या जीरो को बात बराबर है. What does in इसका मतलब क्या है? अगर इनका प्रोजेक्शन एक दूसरे पर जीरो है, then what does it mean? This means, this is very beautiful thing, that all motions or parameters of one axis is independent of other. Now, मैं तुम्हें बहुत छोटा एग्जांपल देता हूँ, तुम्हें बचपन में पढ़ा भी होगा. Let's say if this is the tower, and from here if I am throwing ball, let's say at 10 meter per second, नीचे तो ग्रेविटी लग रही है G, acceleration due to gravity. G is acting this side. So tell me in which direction, right? This is my horizontal and this is my vertical direction. In which direction it will change its motion? Horizontal or vertical?
Vertical.
Vertical.
Horizontal motion will get
Vertical.
No. This you have studied or not? This we have to apply entirely, right? That means vertical and horizontal motions are independent of each other. Why? Because vertical and horizontal are orthogonal to each other. Their motion will not hamper anything. Okay? So what coordinate system you have to study here? Coordinate system कौन कौन से पढ़ने हैं हमारे सिलेबस में? One by one we will study these. अभी तो 2D पढ़ेंगे. पता किसी को?
Cartesian, cylindrical, spherical.
Cartesian, cylindrical, and spherical.
सर पोलर कोऑर्डिनेट भी होता है ना सर?
पोलर कोऑर्डिनेट सिलिंड्रिकल और स्फेरिकल का ही 2D वर्जन है. ठीक है?
ओके सर.
जैसे सिलिंड्रिकल में होता है r, थीटा और h. इसमें होता है r, थीटा एंड फाई. तो h और फाई जो थर्ड डायमेंशन को हटा दोगे तो r, थीटा जो बचा, दैट इज योर पोलर कोऑर्डिनेट. दैट इज इन द सिलेबस. ठीक है? चलो. नाउ वन थिंग दैट इज रिमेनिंग, दैट यू नो दैट क्लीशे, बट ठीक है, बताना तो होता ही है. Mechanics is categorized in two branches. First one is kinematics, and both are in our syllabus, right? And another one is dynamics. है ना? Kinematics, all of you know that. कौन सा होता है? It is study without
cause.
I think cause.
Without the cause. Who is producing the motion? We don't want to do that, right? And here we study the cause. What is the cause? Basically the force. Yes or no?
Yes sir.
Yes.
Now, next thing, when we talk about vectors, you need to understand this thing, that when you write in any coordinate system, सुनना अच्छे से, when you write in any coordinate system, it becomes what? It becomes a scalar. Yes or no? जैसे कि मान लो V is equals to 20 I cap plus 30 J cap. So can I say that when I fix this I cap, it became scalar? Why? Because I have fixed the direction. Because vector is two things. Vector is magnitude as well as direction. Vector is magnitude as well as direction. So understand, vector notation is independent of the coordinate system. But its components are not. So this is a very important thing you need to understand. When we write anything in the vector notation, it is independent of the coordinate system. What coordinate system we uses, but its component is remaining same. सुनना अच्छे से, समझना अच्छे से. Let's say I am defining this vector. दिख रहा है? What is the vector? Vector is something which has some magnitude and which has some direction. As long as I am maintaining its direction and magnitude, vector will not change. Vector will not change. For example, let's say a car is moving in this direction. A car is moving in this direction. Okay? It has speed of 20 meters per second and it is going east. Right? As long as this 20 meters per second is constant and the direction is constant, can I say that the velocity is constant? Yes or no?
Yes, sir.
Velocity is not changing. Okay? So vector are something which has magnitude as well as direction. Now, let me show you something here, that if I have two coordinate system, okay, this was my vector and I am making two coordinate system. एक कोऑर्डिनेट सिस्टम ये है, ठीक है, एंड सेकेंड कोऑर्डिनेट सिस्टम लेट्स से ये. I can choose any coordinate system. So let's say this is x coordinate, this is y coordinate, this is x dash coordinate, it is y dash coordinate. Now x and y is orthogonal and x dash and y is also orthogonal, just they are rotated with angle theta. Now can you tell me the component of this vector on this x dash and the component of this vector on x axis will remain same or change?
Change.
So component of vector A has changed in both coordinate system. अलग अलग coordinate system में ये change हो रहा है. Now tell me one thing. Is the vector changing? Is the vector changing? How we describe the vector? इसकी length देखो, इसकी length अभी भी इतनी है और direction अभी भी point कर रहा है. So when you मान लो if if you are this changing the coordinate system means that means you are rotating your head. When you rotate your head, अगर कोई बाइक वाला इधर से जा रहा है, will it change its motion? No, it will not change its motion. So that's why I'm telling you, ठीक है, कि ये जो कार है, it is again going in 20 meter per second in the east. ठीक है, तुम अगर इधर देख रहे हो तो तुम बोलोगे कि मेरे आगे कार जा रही है 20 मीटर पर सेकंड से. अगर तुम अपने सर को घुमा लोगे, तुम बोलोगे ये कार पीछे जा रही है 20 मीटर पर सेकंड से. बट इन एनी ऑफ द सीन व्हेन यू हैव चेंज योर रेफरेंस फ्रेम, it is not affecting the velocity of this car. Everyone getting it or ठीक है. So one
Yes.
note also you write here, try to end any derivation and deduction. वो ये मैं भी सिखाऊंगा तुम्हें, है ना, बट ये बस याद होना चाहिए. स्टैंडर्ड डेरिवेशन एंड डिडक्शन in the vector form. In your copy. ठीक है, that means if we have to write the second law, which one you will choose? F is equals to dp by dt or F is equals to m ax I cap plus ay j cap plus az k cap. Which one you will choose? One or two?
बोथ ना सर.
वही तो समझा रहा हूँ. टू क्यों चूज करो? टू तो सिर्फ कार्टेशियन के लिए वैलिड है ना. Which is the law? First one or second one?
First one.
फर्स्ट वन
First one.
सर.
First one is valid in every coordinate system, whether you take cylindrical, spherical, Cartesian, जो लेना ले लो, doesn't matter, right? It will have overall applicability. But when you write this thing, that means you are specifying this thing in the Cartesian coordinate system. When we use these things, हम लोग कब एक coordinate system को पकड़ के बैठते हैं? When we are unable to derive it in the vector form. When it is tough to derive in the vector form, then we go into the Cartesian form. So the first one is the superior than the second one equation. Are you getting it?
Yes, sir.
ठीक है, समझ लो ना. अगर मान लो कि ये लेट्स से ये 50 है मीटर पर सेकेंड है और x से एंगल 30 डिग्री है, सॉरी 60 डिग्री है x से, और x डैश से 30 डिग्री है, तो दोनों का कॉम्पोनेंट तो अलग आएगा ना. इससे कितना आएगा? 50 cos 30 डिग्री, और इससे कितना आएगा? 50 cos 60 degree. So there will be difference in the values. So do not write in the component form. Always try to write in the vector form if it is possible. Clear है?
ओके सर.
ठीक है.
Yes, sir.
Orthogonal axes are written in terms of basis, right? In terms of basis. For example, E1 cap, E2 cap, E3 cap, and so on, En cap for n dimension coordinates, for n dimension coordinate, right? Such that ei dot ej, मतलब कोई भी दो का डॉट प्रोडक्ट क्या आएगा? जीरो. कोई भी डॉट प्रोडक्ट क्या आएगा? जीरो. एक एग्जांपल और दे रहा हूं तुम्हें. फॉर एग्जांपल, फॉर 3D कार्टेशियन कोऑर्डिनेट, 3 डायमेंशन है कार्टेशियन कोऑर्डिनेट के. Which all bases are there? I cap, ये तो पता होगा.
जे कैप व के कैप से.
तो I cap, J cap एंड K cap. तो तीन में कार्टेशियन कोऑर्डिनेट में हम लोग I cap, J cap, K cap प्यार से बोलते हैं. बट इफ यू हैव n डायमेंशन, you can use E1, E2, E3, E4, E5, so on, such that any, if you take out any two bases, any two unit vector, basis means unit vector, basis means unit vector. ठीक है, basis means unit vector. ठीक है, is this. So here also you know that I cap dot J cap is equals to J cap dot K cap is equals to I cap dot K cap, that is equals to 0. You know that thing. This is what I am telling you. And this is what? This is the reason behind, this is the reason behind the independency of the coordinate system. It is the reason behind the independency of the coordinate system. ठीक है, चलो यहां तक बताओ. अगर कोई डाउट है तो we will look into the doubt, otherwise we will move ahead.
हाँ सर.
Clear.
Clear? Everyone please raise your hand if it is clear. दो थोड़ा बेसिक से जा रहा है, I know, right? We are covering some very basic part, but trust me, these are required. ठीक है, those who already know these things, these are just kind of revision for you. ठीक है, चलो coming to the, let's revise the Cartesian coordinate system. I hope everyone know these things, but still it's my duty. I have already told you that I will be teaching the basic mathematics, so I will be teaching you. You can lower your hand. Cartesian coordinate system are basically will be dealing in the 3 dimension, है ना. 3D कर लेते हैं. तो this is your card. ये सबको पता है यार. This is the thing. This is my I cap. Let's say this is my J cap. This is the K cap. X, Y, Z axis is, है ना. The motion of one is independent of the motion of another. We know that. ठीक है. Now, what is X? If a point is here, let's say P. If a point is here, we can denote it by having X, Y, Z as coordinate, right? When you join this coordinate with the origin and put an arrow here, it will give you the position vector. Let's say R. So R is the position vector. Okay. If you start making the angle made by this position vector with different axes, right? So they will give you the direction cosines. That is, it is alpha, it is beta, and with the Z axis, it is gamma. Right? Now this reference point, we usually take it as 0, 0, 0. यही तो होता है. What is X axis? What is X? It is the distance from X क्या होता है?
ओरिजिन सर.
YZ plane से distance.
क्या है? YZ plane से distance. Very good. It is distance from the YZ plane. Similarly, Y is the distance from XZ plane, and similarly Z is the distance from XY plane. Right? Now R we call it as position vector. ये क्या है? Position vector. And always remember, position vector is always measured from the reference point. ठीक है? And we can write R is equals to xi cap plus yj cap plus zk cap. This is the position vector that you can. अगर मैं कुछ भी बॉक्स बनाकर, if I'm making the box and coloring it, that means these formula you have to remember. ठीक है? अच्छा, do you know this thing also that here cos square alpha plus cos square beta, ये सारी चीजें 11th की है. अगर किसी को डाउट है तो प्लीज पूछ लेना. cos square gamma is equals to 1.
सर एक बार बता देते इसके बारे में.
इसके बारे में cos alpha,
यस सर.
देखो, what is cos alpha? It is the component of this x and r. ये तो होगा. तो cos alpha is equals to what? X by r. Why? Because x क्या है? Component है ना? That is r cos alpha. यही तो है. Similarly, cos beta क्या होगा तुम्हारा? Y by r. Cos gamma क्या होगा तुम्हारा? Z by r. स्क्वायर कर दो और ऐड कर दो तो क्या आ जाएगा? x स्क्वायर प्लस y स्क्वायर प्लस z स्क्वायर ऊपर आ जाएगा, नीचे आ जाएगा r स्क्वायर. x स्क्वायर प्लस y स्क्वायर z स्क्वायर क्या है? r स्क्वायर है. r स्क्वायर बाय r स्क्वायर कट के कितना आ गया? 1. ओके,
ओके सर.
चलो. Now, when I talk about here I, j and k, they are not just unit vector, they are a constant unit vector. Why constant unit vector? Anyone? They are constant unit vector. When I say a vector,
मैग्नीट्यूड इक्वल टू 1 होता है सर.
magnitude equals to 1 होता है. ओके, और
सर उनका डायरेक्शन चेंज नहीं होता है.
ठीक है. That means
बेसिकली डायरेक्शन और मैग्नीट्यूड दोनों कांस्टेंट है.
that means its derivative will be zero. यही तो बोल रहे हो तुम लोग. अगर ना किसी की डायरेक्शन चेंज कर रही है ना मैग्नीट्यूड चेंज कर रही है तो its derivative will be zero. So when I have to write v, please देखो, हम लोग जब बात करते हैं ना v की, it is dr by dt. There is a logic why I am teaching you like this. dr by dt. What is r? R is basically xi cap plus yj cap plus zk cap अपॉन dt. अच्छा, एक चीज मैं और बोलूंगा. देखो, स्टार्टिंग के 1-2 क्लास में ऐसा लग सकता है कि थिंग्स आर गोइंग वेरी स्लो, थिंग्स आर वेरी इजी, तो कोई बात नहीं, इसको बाद में देख लेंगे, प्रोक्रेस्टिनेट कर लोगे. ट्रस्ट मी, मतलब आई हैव न्यूमरस ऑफ एग्जांपल ऑफ स्टूडेंट जो स्टार्टिंग में बहुत हीरो बनते हैं, सब आता है एंड एट द एंड उनका 20-30% सिलेबस कंप्लीट नहीं होता है. तो प्लीज डू नॉट फॉल इन ट्रैप. अल्टीमेटली धीरे धीरे चीजें पाइल अप होगी और तुम्हें लग जाएगा कि जो नहीं आता था वो आना स्टार्ट हो गया. ठीक है, तो अगर कुछ आ भी रहा है देन ट्राई टू रिवाइज इट. ठीक है, sit with open mind only. dx by dt, how we can write it? We can write it as dx by dt I cap plus x di cap by dt. This is the proper differentiation. समझ आ रहा है? So when you are solving any numerical or something, you have to do like this: dy by dt j cap plus y dj cap by dt plus dz by dt k cap plus Z dk cap by dt. Now we know that these are constant. That means di by dt will be 0, dz by dt will be 0, and dk by dt will be 0. Right? Now I can write simply that vector v can be written as dx by dt I cap plus dy by dt j cap plus dz by dt k cap. It is applicable only when I am taking I, j, k cap as constant, right? Now, write a note. You can use Newton notation to save space. What is Newton notation? Only for rate of change. याद रखना न्यूटन रोटेशन इज ओनली फॉर रेट ऑफ चेंज, दैट मींस टाइम डेरिवेटिव, बाकी सब के लिए वैलिड नहीं है. It is only for time derivative, right? And it simply says that Newton rotation is that if you have vector a dA by dt, if you have to write, you can simply write it as a vector dot ठीक है. या तुम्हारे पास है dA by dt, let's say I cap, you can simply write that a dot I cap. अगर तुम्हारे पास है d square a by dt square I cap, you can simply write it as a double dot I cap, right? One dot means time derivation, time differentiation with it. ठीक है, एक बार टाइम के साथ डिफरेंशिएट करोगे तो एक डॉट लगाओगे, राइट? सो यू कैन राइट दैट व्हाट इज v? V is nothing but x dot means dx by dt plus y dot plus z dot. And a क्या होगा लिखकर बताओ तुम लोग. Try to write the a and tell me. A is what? d square x by dt square. तो क्या करेंगे हम लोग?
x double dot I cap plus y double dot j cap plus z double dot k cap sir.
Very good. X double dot y cap, y double dot j cap plus z double dot k cap. ठीक है. Please revise it a minute. जो पढ़ाया एक बार रिवाइज करो, कुछ डाउट है तो पूछो. Then we will enter into the plane polar coordinate. These are the basics of various topic. ठीक है, कहाँ प्लेन पोलर कोऑर्डिनेट आता है? You know that the central force motion is a plane motion, planar motion. I will tell you how it is a planar motion. See, it will be useful here. First, Rutherford scattering, again a central force motion, two body problem, again next conservation of angular momentum and central force motion, right? So please try to understand it very, very properly. plane polar coordinate is very important in all those 4 topics. ठीक है? So we have started with the equation of motion, but in all those topics it is very important. So plane polar coordinate system is a 2D version of any spherical system or cylindrical system. ठीक है? Let me show you. This is my cylindrical system. ये गोल गोल होगा और सिलेंडर बन जाएगा. ठीक है? This is my spherical system. At the end of the day, whether you take sphere or cylinder, on 2D it is something like a circular. On 2D it is something like circular, and circles are made of few arcs. Circles are made of few arcs. Okay? So how we do that? Let's get into it. Okay? So we will be taking these coordinates x, y. This is my x-axis, this is my y-axis, right? Now when we talk about plane polar coordinates, these are 2D coordinates dealing with measurement of space, in radial and angular distance. Radial and angular distance. That is, the coordinates are r and theta. जैसे Cartesian coordinate में, what is our coordinate system? X and y. Here we have r and theta. ठीक है? So this vector r, and it will have some angle with this x-axis. Remember this thing. So in terms of r and theta, r is the strength where it is going, right? So can you tell me, is r remain same or it will change? If you have to write r here, r क्या होगा?
R सेम होगा ना सर?
ये तो कुछ x एक्सिस होगा, ये कुछ y होगा, बताना मुझे. If I have to write r here, r will be equals to x square plus y square, है ना? And what will be theta? Theta will be tan inverse y by x. Tan inverse y by x. Now, if I have to write it, what I will do? What is r? R is nothing but distance of a point from origin. Distance of a point from origin. From origin, how much is distance? For example, let's say if my point is here, then this will become my r. If my point is here, this will become my r. The distance from the origin is r here. What is theta? What is theta? It is angle made by vector r. Vector is what? Vector है क्या? Position vector. What is position vector? Vector connecting the point and the origin. Position vector with x-axis. With positive x-axis. ये दो बातें बहुत अच्छे से ध्यान रखनी है, right? The first thing, that plane polar coordinate deals with the r and theta concept. What is r? R is distance from the origin, right? And theta is what? Angle made by the positive axis. अच्छा, what is? Does r necessarily need to be constant or it can change?
थीटा से.
हाँ,
थीटा चेंज होगा ना सर?
r change नहीं सकता. Can r change?
नो सर, सिलेंड्रिकल और स्फीयर में तो आर को कांस्टेंट रहना होगा ना सर?
वेरी गुड आयुष। अब देखो समझो, लाइफ में नॉट एवरी कर्व मोशन इज सर्कुलर, ठीक है। इट इज, दिस इज यूजफुल इन एनी कर्व लीनियर मोशन, एनी कर्व वाले मोशन में ये यूजफुल है, प्लेन कोऑर्डिनेट, राइट। व्हेन r is constant it is circular, right? When r is constant it is circular. तुम समझो the motion can be circular, the motion can also be spiral ना,
Yes, sir.
the motion can also be helix, इन सब में सर्कुलर मोशन वाला फॉर्मूला लगता है, इन सब में रेडियल मोशन का फॉर्मूला लगता है, ये सुनो। सो ट्राई टू अंडरस्टैंड, द मोशन कैन बी हाइपरबोलिक, मोशन कैन बी हाइपरबोलिक। एक प्लस पॉजिटिव चार्ज है और यहाँ पर बहुत ज्यादा पॉजिटिव चार्ज है, तो ये क्या करता है, रिफ्रैक्ट करता है, रदरफोर्ड स्कैटरिंग। दीज ऑल आर सेंट्रल फोर्स मोशन एंड दे ऑल इन्वॉल्व प्लेन पोलर कोऑर्डिनेट। So please try to understand that it is not only about the circular motion but all the associated curvilinear motions, ठीक है। That means it is circular motion, it is spiral motion, it is helix motion, all things we have to study. It is hyperbolic motion. So in every scenario it will work, ठीक है। चलो आगे। Now few derivations we have to do. Again take, this is r and this is theta, ठीक है। Now we have to construct something based on this, ठीक है, we have to construct something based on this. So what I will be doing here, that what is r cap? If I ask you what is r cap, अरे किसी वेक्टर में अगर लेट्स से इसमें a
Unit
वेक्टर,
vector along
yes,
R.
इसी में एक एक यूनिट ले लो, यही मेरा हो गया a cap, ये सुनो। So the direction along that vector is represented by that cap. So r cap will be in this direction, yes or no? This is my r cap. Where will be theta cap? Where will be theta cap?
ऑर्थोगोनल, इसके ऑर्थोगोनल रहेगा ना सर।
Very good. So for example, if this is circular motion is going on, it is an anti-clockwise motion. So what is the direction of this motion? It is out of the plane, yes or no? If it is going like this, it will be into the plane, yes or no? ये बात सब लोग समझ रहे हो ना कि थीटा इज एक्सियल वेक्टर, ये ऐसे रोटेट करता है, राइट। So when any axial vector is there, we use which rule? Which rule?
The right hand thumb.
Right hand thumb rule. Very good. Right hand thumb rule. Please किसी को डाउट है तो पूछते चलो, ये चीजें दोबारा नहीं होंगी, है ना। And if you miss it, you will miss complete thing. Right hand thumb rule. That means if you use the right hand thumb rule, this will be the direction of theta, perpendicular to that. Theta cap, ठीक है। अब now I want you guys to just have the component along x and y. ये तुम्हारा x है, और ये तुम्हारा y है। कंपोनेंट करो, तुम लोगों को करना है, डू इट। I will teach you everything, but you also have to do some hard work. X cap कह लो या I cap कह लो, I cap, I cap, और ये है J cap। ये थीटा है तो ये भी थीटा, ये थीटा तो ये 90 माइनस थीटा, तो ये थीटा।
सर इसमें करना क्या है, थोड़ा क्वेश्चन समझ नहीं आया।
कॉम्पोनेंट में तोड़ना है, आर को आई और जे
आर
के
को या अच्छा आर को आई और जी के
Sir, R will be R cos theta plus R sin theta. R cos theta I cap plus R sin theta j cap.
ओके।
And theta will be theta will be cos theta j cap. Sorry, cos theta j cap and minus sin theta I cap.
ठीक है, गुड। इट इज जे कैप, है ना, इट इज आर, इट इज थीटा। ठीक है, अब देखो इन ये सब वेक्टर कैसे है, दीज ऑल आर यूनिट वेक्टर, दीज ऑल आर यूनिट वेक्टर। सो प्रोजेक्शन लेते हैं, है ना। सो इफ दिस इज आई, दिस विल बी माइनस आई कैप, ये तो है। So let's take the projection. Here projection will be here also. Projection will be here. Okay. So on this, what will be the projection? If it is r cap, this is theta, and this is theta. So here it is cos theta, and here it is sin theta. ये तो सबको समझ आ रहा होगा, है ना। And for this, here it is cos theta, and here it is sin theta. Here it is sin theta, right? Now write it, that r cap will be equals to cos theta I cap plus sin theta j cap। आई थिंक ये तो सबका सही हुआ होगा, है ना। एंड थीटा में गड़बड़ हो सकता है कुछ लोगों से, प्लस माइनस का। एंड थीटा कैप विल बी इक्वल्स टू माइनस साइन थीटा आई कैप। क्यों, आई कैप कौन सा इसमें माइनस वाला है, बट वो तो पॉजिटिव है, cos थीटा जे कैप। कितनों का आया ये चीज, जस्ट रेज योर हैंड। वेरी गुड। So I hope you guys have understood this thing, है ना, r और theta. Now what is the analysis you can do, everyone? This is what we have got here, right? What analysis we can do here? इसका interpretation क्या आएगा? If we have to interpret these two equations, what all we interpret here? बताओ। Exam may be when you are solving any derivation, when you are solving any question, you will end up in any numerical or you will end up in any equation. Yes or no? What is the interpretation?
Sir, R cap dot theta cap will be 0. दोनों का dot product will be 0.
Very good. So the first you are saying that, so first interpretation मैं लिख देता हूँ, ठीक है, that जो दिख रहा है कि इसमें भी थीटा है, दोनों में थीटा है, that means both are theta dependent. Yes or no? Yes or no? Both are theta dependent. Earlier, what used to happen when we are solving I cap, J cap, K cap? No one is dependent upon each other. I cap is not dependent upon J cap is not dependent upon this, right? Here, what is happening here? That theta has a significant role in R as well as theta. Yes or no? So both are theta dependent. Second interpretation that I can write, तुमने जो बोला एकदम सही है, वो लास्ट में लिख लेंगे, ठीक है, that the magnitude of both is 1. देखो करके देखो, दोनों का क्या आ रहा है, cos square theta plus sin square theta, that is equals to 1. And the third thing that you have to focus, that you have said very correctly, that r cap and I'm writing bracket theta. Why? Because r cap is a function of theta as well as theta cap, which is still a function of theta, but they are independent. They are zero. That means they are set of orthogonal axes. They are set of orthogonal axes. One means that they are unit vectors. Right? So when two vectors are unit vector and form a set of orthogonal axes, that means they can be used in a coordinate system, and that we are using in a plane coordinate system. Yes, Ayush?
सर थर्ड जो कंडीशन है वो हमने अज्यूम करी थी ना कि वो ऑर्थोगोनल है जब
नहीं
आपने
नहीं
आर और थीटा में 90 डिग्री एंगल दिया था तो वो अज्यूम है ना अज्यूम्ड है ना कि वो ऑर्थोगोनल है
नहीं, अज्यूम नहीं है, अज्यूम नहीं है, वो हमारे डायरेक्शन से आ रहा है ना। जैसे अगर मान लो अगर कोई एक ये है, लेट्स से देखो इसको, अगर ये कोई गोल चीज घूम रही है, ठीक है, टेक वन एग्जांपल हियर, वी आर हियर, लेट्स दिस पॉइंट, सो this will be my direction of r. Yeah, yes or no? Sir, if it is moving in this direction, this tangential will be the function of theta. Yes or no?
थीटा
बोलते हैं ओमेगा, let's say ओमेगा, तो ओमेगा की डायरेक्शन क्या हो जाएगी? ये व्हाट इज ओमेगा? ओमेगा इज d theta by dt. Yes or no?
हाँ यस
ठीक है, so if it is moving in this direction, this will be the theta cap. Okay, so we generally refer to that this is acting in a radial position and this is acting in a tangential position. So see, finding out radial is very, very easy. You just need to find out what? The point and the origin. You just need to find out which point is our consideration and what is our origin. If you join both of them, you can find the radial easily. है ना? And perpendicular to that will be tangential, right? So radial
yes
is along direction joining origin and object. Okay, and this all we will be seeing in the central force motion, a very beautiful topic of mechanics, central force motion. Okay, now coming to the its derivatives. अब यहां से you also have to do work. ठीक है, so the first derivative that you have to do is find out dr by dt in terms of r and theta only. R and theta, you have to find out dr by dt. Giving you 2 minutes. Do it. आयुष बता सकते हो, ऐसा कोई इशू नहीं है। चलो ओके, हाउ मेनी डिड दैट? ये तो हो गया, चलो वेरी गुड। ठीक है, सो व्हाट इज आर? पुट कर दो ऊपर से, डी कॉस थीटा आई कैप प्लस साइन थीटा जे कैप। नाउ आई जे आर, आई एंड जे आर कांस्टेंट बट नॉट थीटा, है ना? आई जे एंड आर कांस्टेंट बट नॉट थीटा। दिस जिनका नहीं हुआ है कोई बात नहीं, देखो डी
डी
कॉस,
cos थीटा आई कैप प्लस डी sin थीटा बाय डी टी जे कैप।
लास्ट आंसर क्या है वो बताओ।
हाँ सर, डी sin थीटा बाय सॉरी डी cos थीटा बाय डी टी आई कैप प्लस डी sin थीटा डी टी बाय जे कैप।
यू हैव टू राइट इन टर्म्स ऑफ आर एंड थीटा ना, ये तो ठीक है। अब नेक्स्ट स्टेप इट विल बी व्हाट, वी विल डिफरेंशिएट इट, है ना? तो इट विल बी व्हाट, डी कॉस थीटा बाई डी थीटा अपॉन डी थीटा बाई डी टी। क्या, कौन सा रूल बोलते हैं उसको? व्हाट रूल इज दिस?
चेन रूल।
बिकॉज इट इज
Chain
नॉट अ
rule.
फंक्शन। यस, वेरी गुड।
सच एंड
And again d theta by dt j cap. Now d cos theta by d theta is equals to minus sin theta, and d theta by dt is what? Theta dot, अभी बताया था नोटेशन, I
Yes, sir.
cap plus here it will become cos theta theta cap into j cap. Now you can simply take this as common, minus sin theta I cap plus cos theta j cap into theta cap. ये तो r कैप है, सॉरी ये तो थीटा कैप है। दिस इज आवर व्हाट, थीटा कैप, थीटा डॉट, और यू कैन सिंपली राइट एज थीटा डॉट थीटा कैप, थीटा डॉट थीटा कैप। ठीक है, सो वन फॉर्मूला यू शुड राइट हियर दैट dr by dt, ये तुम्हें याद करना होगा, दैट इज थीटा डॉट बाई थीटा कैप, थीटा डॉट बाई थीटा कैप। Okay, so once you have done this thing, do it for d theta by dt. You can lower your hand now, Surendra, you can lower your hand. d theta cap by dt, बताओ जल्दी से, giving you 1 minute, ये जल्दी करोगे, और कुछ भी रफ फेयर नहीं होगा, सब कुछ सेम कॉपी में होगा, है ना? तो इट इज, साथ कर लेते हैं, माइनस डी साइन थीटा आई कैप प्लस डी कॉस थीटा जे कैप बाई डी टी। ठीक है, आई एम नॉट राइटिंग द चेन रूल नाउ, आई नो यू कैन अप्लाई। तो साइन का क्या आ जाएगा, माइनस साइन का माइनस कॉस थीटा इंटू थीटा कैप आई माइनस साइन थीटा थीटा डॉट जे कैप, take it away, that is minus of this, दो क्या आ रहा है, minus, if you take it, it will become cos theta I cap plus sin theta j cap into theta cap, that is equals to minus theta dot, वो क्या है, it is r cap. So can I write that d theta by dt is equals to minus theta dot r cap? कितनों का है ये?
सर आ गया।
Now what is velocity? Velocity is basically rate of change of Position. Velocity is nothing. Velocity is a definition.
Position.
Rate of change of position. Now, what is rate of change of position here? This V will be equals to dr by
dr by d.
very good dr by dt, right? Can I write this dr by dt as dr r cap by dt? लिख सकते हैं ना? Any
Yes,
vector
sir.
can be written as like that, है ना? Which is equals to dr by dt r cap plus r dr cap by dt. अब पुट कर दो चीजों को. If you put it, what is dr by dt? It is r dot r cap plus what is dr cap by dt? अभी ऊपर निकाला है हमने, देखो theta dot theta cap, that is r theta dot theta r theta dot theta cap. कितना आ गया ये? How many of you got this one for velocity? ठीक है, चलो अब करो इंटरप्रिटेशन. गिविंग यू 2 minutes for the interpretation part. Giving you 2 minutes for the interpretation part. ठीक है, इंटरप्रेट करो.
Net velocity is depending on radial velocity and tangential velocity.
और कुछ केसेस बना सकते हो क्या?
Yes, sir. सर अगर r कांस्टेंट हो in that case केस बन सकता है r dot will be 0, then second term बचेगा वहाँ पे, and
Okay, go on.
for circular motion
तो यहाँ पे हम लोग दो चीजें कर सकते हैं. एक तो है हमारी रेडियल वेलोसिटी, है ना? व्हाट इज रेडियल? व्हिच इज अलोंग द रेडियस, आर कैप वाली चीज है. सो इफ वी focus on the radial velocity, first thing I can write that it is along the radius or radial direction जो हमने पढ़ा है. ठीक है, if it is along the radius or radial direction, what does it mean? It can increase or decrease the radius of the curve. ठीक है, समझिए चीज को. अच्छा नीचे से समझाता हूं, मतलब समझो that if a motion is here and if velocity is in this direction, इस direction में है, so what it can do, it can either, if velocity is increasing, it can increase the radius or it can decrease the radius. It can increase the radius or it can decrease the radius, right? So circular motion अगर हो रहा है, so what will be the radius of the circular motion? It depends upon the radial velocity, right? So the radial will depend upon the radial velocity. ठीक है. Third thing, that is VR, we write something like that, VR radial, that is equals to r dot r cap. R dot r cap. Now can you tell me when it will be 0? 0 when r dot is 0. R dot is 0 मतलब इसका डेरिवेटिव 0 है, that means r is constant. When it is constant? When it is constant?
circular motion.
circular motion. Very good.
Yes.
In the circular motion. So you will see that there is no radial velocity in circular motion. Only velocity that it contains is the radial motion. Okay. Now, next interpretation is the tangential. Tangential velocity. Okay. What it can do? It is along the direction perpendicular. It is along the direction perpendicular to radius. Okay. Second, it changes the direction of the motion. It is responsible for changing the direction of the motion. Whether it's going in the straight line or not, it is okay. That means it helps in moving in curved path. If it is 0, that means it will be straight. It helps in moving in curved path, right? Fourth, तुम्हें याद रखना होगा VT है ना, ये तो बोलते हैं हम लोग. VT is what? कितना आ रहा है? R theta dot theta cap. Sometimes we write theta as omega also. So R omega theta cap. सुना होगा ना? Omega R omega. Have you heard about this thing? So
Yes.
R omega theta cap. तो ओमेगा होगी तभी ये चीज होगा. Now I am making one table. ठीक है. VR is 0 and VT is equals to 0. VR is equals to 0 and VT, we are not equals to 0, VT equals to 0. And next, we are not equals to 0 and VT is also not equals to 0. Okay. Their condition, you have to write the trajectory. Okay. These are the condition. You have to write the trajectory. Do it. बताओ फर्स्ट की ट्रैजेक्टरी क्या होगी, सेकंड की क्या होगी, थर्ड की क्या होगी? कितने लोग थक गए? आज 10:30 में छोड़ दूंगा, टेंशन मत लो. ठीक है, मुझे लग रहा है बहुत तो थक गए.
सेकेंड का तो सर्कुलर मोशन हो जाएगा ना सर, और फर्स्ट का थर्ड का लिनियर मोशन है.
सॉरी, VT नॉट इक्वल टू 0. दोनों 0 तो मतलब क्या है, मोशन ही नहीं होगा फिर. इट इज नॉट इक्वल टू 0. फर्स्ट क्या है? नो रेडियल वेलोसिटी. सुनना अच्छे, सोचना अच्छे से, दिमाग में ऐसे चलना चाहिए. नो रेडियल वेलोसिटी मतलब along the radius nothing will happen. That means radius will not change. When radius is not changing and we have tangential motion, it is the case of
सर्कुलर मोशन सर.
circular motion. Very good. Now next is VR is 0. That means radius can change.
लिनियर
Radius
मोशन
can,
सर.
sorry, but there is no tangential motion. That means direction is not changing. समझो अच्छे से, ये क्या कर रहा है? It is changing the radius, it is changing the direction, right? So here no radial is not changing, direction is changing, that is circular. Here radius is changing, that means it can go, ये इस डायरेक्शन में जा सकता है और इस डायरेक्शन में जा सकता है. But there is no curve motion. Why? Because VT is 0, no change in direction. That means इधर जाना, इधर जाना, इसको क्या बोलते हैं हम लोग? स्ट्रेट मोशन.
लिनियर मोशन.
ठीक है, और रेक्ट लीनियर मोशन। एंड जब दोनों है नहीं है तो ये क्या होगा, कर्व लीनियर मोशन, है ना। यहां मैंने तो बताया था, देखो अगर ये ऐसे जा रहा है तो ये क्या है तुम्हारा, रेक्ट लीनियर, और ये सारे तुम्हारे क्या है, हेलिक्स, हाइपरबोलिक, सब कुछ, दीज ऑल आर कर्व लीनियर मोशन। Those both all are curvilinear motion, that will it will contain the radial part as well as the tangential part. ठीक है, एक्सेलेरेशन भी कर ले, कितने लोग रेडी हो एक्सेलेरेशन करने के लिए, कर लेते हैं
यस
ना।
सर।
यस
यस सर।
तो लास्ट एक्सेलेरेशन कर लेते हैं, न्यूमेरिकल्स हम लोग कल करेंगे। निकालो फिर, व्हाट इज एक्सेलरेशन, इट इज रेट ऑफ चेंज ऑफ वेलोसिटी, it is rate of change of velocity. Giving you 3-4 minutes सॉल्व करने के लिए। इतना तो सबको समझ में आ गया होगी, A is equals to dV by d। And what is V, अभी जस्ट निकाला हमने, d r cap, sorry r dot r cap plus r theta dot theta cap by dt। सबका डिफरेंशिएशन रेडीमेड है तुम्हारे पास ऑलरेडी ऊपर। क्या लिखेंगे, फर्स्ट वाले को डिफरेंशिएट करेंगे, आर कैप, तो क्या आएगा, आर डबल डॉट आर कैप प्लस आर डॉट डी आर कैप बाई डी टी। इन दोनों करेंगे तो ये तो आएगा, प्लस यहाँ पर 3 है तो पहले आर को कर देते हैं, तो आर डॉट थीटा कैप, फिर आर को बाहर निकाल कर लेते हैं, तो थीटा डबल डॉट और थीटा कैप, प्लस आर और थीटा दोनों को रख लेते हैं, आर डॉट थीटा डॉट, तो क्या आ जाएगा ये, डी थीटा कैप बाई डी टी। अब डी आर बाई डी टी और डी थीटा बाई डी टी तुम्हें आता है ऑलरेडी, पुट वैल्यूज, पुट दी वैल्यूज, तो आर डबल डॉट आर कैप प्लस आर डॉट डी और डी टी क्या पढ़ा है हमने, थीटा डॉट थीटा कैप, जिसका हो जाएगा प्लीज रेज योर हैंड, आर डॉट थीटा कैप, मेरे को सौम्य, प्लस आर थीटा डबल डॉट थीटा कैप प्लस आर थीटा डॉट माइनस थीटा डॉट आर कैप। अब जितनी भी आर कैप वाली चीजें हैं उनको एक साथ कर लो, है ना। सो ओके सुरेंद्र, गुड, आर डबल डॉट आर कैप, और कहीं आर कैप है, हाँ लास्ट में है, माइनस आर थीटा डॉट स्क्वायर ये है ना माइनस आर, हाँ ठीक है, जेड डॉट स्क्वायर आर के प्लस, देखो क्या क्या हो सकता है, ये दोनों सेम ही है, आर डॉट थीटा डॉट, आर डॉट थीटा डॉट, तो 2 लिख देते हैं, सो 2 आर डॉट थीटा कैप प्लस आर डबल थीटा थीटा कैप, ये बन गया हमारा इक्वेशन। A is equals to r double dot minus r theta dot square, ये किसी भी कर्व मोशन का क्या है, एक्सेलरेशन है, इट इज द एक्सेलरेशन ऑफ एनी कर्व मोशन, राइट, 2r dot theta dot plus r theta double dot theta इंटरप्रिटेशन। चलो इंटरप्रिटेशन मत करो अभी, इसका इंटरप्रिटेशन होमवर्क है। ठीक है, मैं यही लिख दे रहा हूँ होमवर्क, स्मॉल स्मॉल होमवर्क आई विल बी गिविंग यू एंड प्लीज डू इट। होमवर्क मैं देखना चाहता हूँ तुम लोग कैसे लिख के लाते हो। इंटरप्रेट द अबव इक्वेशन। ठीक है, गिविंग यू 2 मिनट्स, जितना भी पढ़ाया है एक बार सबको रिवाइज करो। सबका हो गया ना यहाँ तक? प्लीज रेज योर हैंड, हैव यू रिटन टिल हियर? यस, गो टू द फर्स्ट पेज ऑफ योर नोटबुक एंड स्टार्ट रिवाइजिंग। ठीक है, एक बार सबको देखो, गिविंग यू 2-3 मिनट्स, डू इट। ओके, स्टार्ट करते हैं हम लोग। आज क्या क्या देखा किया हमने, जल्दी से क्विक रिव्यू करते हैं। ठीक है, सो in today's lecture we have started with the syllabus of the mechanics, right? Here we have started with the equation of the motion, right? Introducing the classical mechanics. What is the domain of classical mechanics, right? It is applicable on the distinguishable macroscopic object only, right? It can be identical but it should be distinguishable. Okay, we have understood the concept of particle. What do you mean by particle, right? Next, what is event and observer? Next, we have studied the concept of space, time and coordinate space. Also, we have understood that what all things are required to make a coordinate axis. The main feature is the orthogonality of the axes. Then we have came across the some properties of vector that is important for us, and then the Cartesian coordinate system. Cartesian coordinate system are the easy one that you have already studied in your junior classes. The main focus that we have to give from the plane polar coordinate. You can start make a star mark also. This is very, very important. From now onwards, all the important and relevant things will start. So plane polar coordinates, we have seen the different type of curvilinear motion, which can be demonstrated by these things, right? Also, we have started few note wala thing that will help you in writing the answer. And also I have started giving you how to interpret the thing, how your mind should work, right? In the very first classes, right? Again, this thing we have written and the interpretation is done for the homework, right? How many of you have understood everything that we have taught in the class? सब कुछ समझ में कितना वो आ गया है?
Yes.
सब 90% से ऊपर, ठीक है? Okay, so tomorrow what we will be doing? Tomorrow we will be doing basics of vector calculus and Newton's laws of motion. Okay, these two topics we will be doing in the next class. Okay, any doubt? Anyone? Those who don't have any doubt can leave the class. If you have any doubt, बताओ.
सर पॉइंट ऑब्जेक्ट का जो फर्स्ट एग्जांपल आपने बताया था, तो उसमें मुझे कुछ समझ में नहीं आया. वो जो
ये बोलो, अगर तुम्हारे पास एक गाड़ी है जिसकी लेंथ 5 मीटर है और वो 20 मीटर ट्रेवल करती है, ठीक है? तो उस 20 मीटर में तुम गाड़ी की विड्थ भी जोड़ोगे ना, कितना ट्रेवल किया, क्योंकि 20 मीटर के हिसाब से 5 मीटर का डिफरेंस बहुत ज्यादा डिफरेंस होता है. ये सुनो,
यस सर,
समझ रहे हो? फॉर एग्जाम्पल, लेट्स अंडरस्टूड इज बाई पार्किंग स्पेस. जब हम पार्क करते हैं तो क्या गाड़ी की साइज मैटर करती है ना? क्योंकि जिस स्पेस में हमें पार्क करना है, जिस स्पेस पे गाड़ी चलेगी और जो गाड़ी की साइज है वहां पे वो कंपेरेबल है. ये सुनो.
ये सर, तो यहाँ आर जो है ज्यादा हो रही है ना सर, 20 मीटर में.
आर तो कम हो रही है ना, कंपेरेबल हो रही है ना. 5 मीटर 20 मीटर तो बराबर ही है ना, ऑलमोस्ट.
जी सर, जी सर,
देखो
ठीक
ये
है
5
सर,
मीटर,
समझ गए. हाँ हाँ सर जी,
ये
मीटर
10
है जी.
15 मीटर, ये 20
जी
मीटर.
जी
अब इतने
जी सर,
जगह
जी.
पे अगर की गाड़ी खड़ी है तो इट इज कंपेरेबल. बट अगर तुम 10 किलोमीटर दूर, अगर तुम 1 किलोमीटर दूर देखो ना, तुम्हें गाड़ी बहुत पॉइंट
हाँ सर,
दिखती है.
सर थोड़ा सा मिस्टेक हो गया था, किलोमीटर मीटर में थोड़ा मिस कर दिया था मैं.
मीटर. ओके, और कोई डाउट?
सर सर वो सबसे पहले जो आप डिस्टिंग्विशेबल पार्टिकल पढ़ा रहे हैं, उसमें सर ये पूछना है कि जैसे कोई बॉक्स है, उसमें गैस मॉलिक्यूल्स हैं, तो सर उनको क्या कहेंगे? आइडेंटिकल पार्टिकल्स हैं और वो डिस्टिंग्विशेबल होंगे कि नहीं? और उनमें ये हम एनालिसिस उनकी ट्रेजेक्टरी को कर सकते हैं या नहीं?
देखो, अगर वो गैस पार्टिकल है तो हम उसे डिस्टिंग्विशेबल मानते हैं. ठीक है, चाहो तो यहाँ लिख लो.
अच्छा, वो डिस्टिंग्विशेबल है, ठीक है सर.
सर एक मिनट सर, वहाँ जो आपने सिस्टम इफेक्ट द सिस्टम जो लिखे सर, लेकिन जब हमने यहाँ 1 2 3 4 को चेंज किया तो सिस्टम में तो कोई भी इफेक्ट नहीं आ रहा है. डिस्टिंग्विशेबल जो है वो सर, उसमें चेंजिंग पोजीशन इफेक्ट द सिस्टम.
हाँ, यहाँ पे इफेक्ट तो आना चाहिए ना. वही तुम बता रहा हूँ कि अगर तुम 1
हाँ.
मीटर करोगे तो 4 कितना ट्रेवल किया. लेट्स से मान लो ये 1 मीटर है, ये 2 मीटर, ये 3 मीटर है, तो 1 ट्रेवल किया 3 मीटर और 4 ट्रेवल किया 1 मीटर. अगर तुम उसकी ट्राजेक्टरी पहचान पा रहे हो कि 1 3 मीटर ट्रेवल किया और 4 1 मीटर, तो सिस्टम चेंज हो गया ना.
यस सर.
ठीक. अभी सुनो, ये जो पोजीशन है, ये वाली चीज है, ये तुम्हें तब समझ आएगी जब तुम पढ़ोगे क्वांटम मैकेनिक्स, क्योंकि तब तुम क्वांटम सिस्टम को समझ पाओगे. मैंने लिखवाया था ना क्वांटम पार्टिकल्स. ठीक है, अभी क्योंकि हम इस चीज को विजुलाइज नहीं कर सकते अभी, है ना, तो हमें किस पे फोकस करना है? हमें फोकस करना है ट्राजेक्टरी पे. ठीक है, अगर हम ट्राजेक्टरी को एनालाइज कर सकते हैं तो ठीक है, अगर नहीं कर सकते तो नहीं. ठीक है, सिस्टम क्या होती है, सिस्टम कैसे फिट होता है, ये हम पढ़ेंगे आगे चल के भी. ओके,
ठीक है सर, थैंक यू.
सर क्लासिकल मैकेनिक्स डिस्टिंग्विशेबल पार्टिकल्स और मैक्रो पार्टिकल्स को डील करता है.
हाँ, मैक्रो ऑब्जेक्ट में कैसे पार्टिकल? डिस्टिंग्विशेबल पार्टिकल्स. ठीक है
सर मैक्रो ऑब्जेक्ट में नॉन आइडेंटिकल मतलब नॉन डिस्टिंग्विशेबल पार्टिकल्स भी हो सकते हैं,
नहीं,
मतलब इनडिस्टिंग्विशेबल.
पार्टिकल जनरली माइक्रोस्कोपिक ही होते हैं. मतलब ये एक तरीके से कह लो ओवरलैप है कि मैक्रोस्कोपिक ऑब्जेक्ट डिस्टिंग्विशेबल होते हैं और माइक्रोस्कोपिक जो है वो इनडिस्टिंग्विशेबल होते हैं. ठीक है, माइक्रोस्कोपिक में कई बार ऐसा होता है कि वो डिस्टिंग्विश हो जाए, बट मैक्रो तो होता ही होता है. ठीक है, चलो, मतलब all the classical mechanics are effective on distinguishable object. Those are mostly macroscopic in nature. Some microscopic object can also be there, but mostly it is macroscopic. ठीक है,
यस
एग्जांपल
you,
सुन के जाओ, समझ के जाओ लोगों।
Yes.
वो पढ़ा है बोर मॉडल। तो
Yes,
बोर
sir.
मॉडल देखा होगा कि न्यूक्लियस है एंड यहाँ पे इलेक्ट्रॉन है, और फिर उस पे हम न्यूटन्स लॉ ऑफ मोशन लगाते हैं, है ना, k q1 q2 by r square is equal to mv square by r, लगाते हैं ना क्लासिकल
हाँ,
मैकेनिक्स कॉन्सेप्ट। यस और नो?
हाँ सर,
देयर, यस और नो?
यस सर,
देयर इलेक्ट्रॉन इज व्हाट? Microscopic object, but it is distinguishable, so we will consider it in classical mechanics. ठीक है?
यस यस सर।
Okay, anyone else? खत्म? ठीक है, चलो, थैंक यू सो मच, गुड नाइट।
थैंक यू सर।
Sir,
हाँ पूछो।
non-identical particles will always be distinguishable.
नॉन आइडेंटिकल पार्टिकल
Will always be distinguishable.
हाँ हाँ, अगर वो नॉन आइडेंटिकल ही हो गए तो तुम डिस्टिंग्विश कर सकते हो ना। दो तुम्हारे पास एक लाल बॉल है, एक पीला बॉल है, यू कैन डिस्टिंग्विश इजीली, यस और नो? इंडिस्टिंग्विशेबल कब आती है? जब तुम्हारे पास इलेक्ट्रॉन्स, बहुत सारे इलेक्ट्रॉन्स है, अब सब इलेक्ट्रॉन पे चार्ज भी सेम, मास भी सेम, दिखते भी सेम, तो वहां पे दिक्कत आती है। ठीक है,
Sir,
Got it?
chaotic का example dominant है.
सी chaotic सिस्टम को हम डिफाइन ऐसे करते हैं जो इन रूल्स को फॉलो नहीं करते हैं। ठीक है, दैट इज जस्ट फॉर, मतलब वो थ्योरी है मैथमेटिक्स की, तो उसमें जाना एकदम ही बकवास है। ये जस्ट, मैंने क्या लिखा, ये वैल्यू एडिशन के लिए है। कुछ चीज ऐसे होती है जो मैं, ये सिर्फ वैल्यू एडिशन के लिए एक्सेप्शन, कि अगर तुम कंक्लूजन कहीं लिख रहे हो तो एक लिख दो कि नॉट वैलिड फॉर chaotic सिस्टम। ठीक है, बस इतना वर्ड लिखने से तुम्हारा काम हो जाता है। ठीक है, इट इज नॉट इन योर सिलेबस। ओके, चलो ठीक है, ओके, गुड नाइट एवरीवन, बाय बाय, थैंक यू।